At 0730 hours on July 14, 1944, Sergeant Curtis Culin stood beside a Sherman tank at a training field near Colombières in Normandy, watching General Omar Bradley arrive to inspect a modification that probably violated every regulation in the Army manual. The tank belonged to the 102nd Cavalry Reconnaissance Squadron. Culin was 29 years old, a tanker with the New Jersey National Guard unit that had been attached to various divisions fighting in the bocage. The modification welded to the front of the Sherman was 4 steel prongs cut from German beach obstacles. Bradley had driven out personally to see if this unauthorized field modification could solve a problem that was killing American soldiers by the hundreds every single week. Culin had been working on tanks in Normandy for 5 weeks. He knew armor inside and out. The M4 Sherman was a reliable medium tank, well-armed, mechanically sound, perfect for open terrain. But the Sherman had one fatal problem that was getting American tankers and infantrymen killed every single day in the Norman bocage. It could not get through the hedgerows without exposing its belly armor to German anti-tank fire. The hedgerows were earthen berms averaging 4 feet high, topped with 15 feet of dense brush, trees, and interlocking root systems. They separated every field in the Norman countryside. Centuries of farming had created a landscape perfectly suited for defense. Each hedgerow was a natural fortress. The Germans dug fighting positions directly into the earthen banks, machine gun nests, anti-tank positions, sniper hides, all protected from overhead artillery fire. American doctrine said tanks should climb over the hedgerows to break through. That was the training. That was what worked in England during exercises. But Norman hedgerows were different, thicker, higher, stronger. When a Sherman climbed a hedgerow, the tank tilted upward at a 45-degree angle. The front armor pointed at the sky. The thin belly armor pointed straight at German anti-tank guns hidden in the next hedgerow. The tank could not fire its main gun. The driver could not see forward. For 5 or 6 seconds, the Sherman was completely helpless. That vulnerability meant death. The First Army had lost 231 tanks in June alone. Most were destroyed in the hedgerows. The casualty rate among infantry was even worse. Between June 6th and July 31st, rifle companies lost nearly 60% of enlisted men and over 68% of officers. Entire companies were being chewed apart, advancing field by field through the bocage. The training manual said the problem was poor tactics. The officers said tank commanders were not using proper routes of advance. After-action reports from failed operations cited inadequate reconnaissance, insufficient infantry support, poor coordination with artillery. But tankers and mechanics on the ground knew better. The problem was not the tactics or the training or the coordination. The problem was fundamentally the terrain and how American armor was forced to interact with it. The bocage was unlike any battlefield American forces had trained for. Exercise areas in England had hedgerows, but they were smaller, thinner, less formidable. British hedgerows were agricultural boundaries maintained for a few centuries. Norman hedgerows were ancient earthworks that had been accumulating mass for 1,000 years or more. Some dated back to medieval farming practices. Generations of farmers had piled stones cleared from fields onto the same boundaries year after year, century after century. Trees had grown and died and been replaced by new trees, their root systems intertwining into nearly impenetrable masses. The earthen berms had compacted and settled into structures as solid as fortifications. And the solution everyone kept trying, using combat engineers to blow holes in the hedgerows with explosives, was getting people killed even faster than the climbing attempts. Engineers would approach a hedgerow, set charges, blow a gap, and the explosion would alert every German position within 1,000 yards. German artillery would start falling before the first tank could even move forward. Machine gun fire would sweep the breach. The tanks that made it through were immediately hit by pre-sighted anti-tank guns. The engineers trying to place the next set of charges were shot down. Several units had tried developing their own solutions throughout late June and early July. The 79th Infantry Division had a hedge cutter in operation by July 5th. The 19th Corps demonstrated prongs initially designed for placing explosives. The 5th Corps units created devices dubbed brush cutters and green dozers, but none of these modifications spread widely. Most required specialized equipment or extensive modifications that field units could not replicate. The 102nd Cavalry Reconnaissance Squadron had been discussing the hedgerow problem for weeks. They were a New Jersey National Guard unit, the Essex Troop, with a long history dating back to the Revolutionary War. The squadron had landed on Omaha Beach on D-Day +1 and had been in continuous combat since June 7th. Unlike infantry divisions that rotated units for rest, cavalry reconnaissance squadrons operated continuously. They screened advances, conducted patrols, gathered intelligence, and fought wherever they were needed. The men came from industrial backgrounds around Newark and the surrounding areas. Many had worked in factories, machine shops, repair facilities before the war. They understood mechanical problems. They knew how to work with their hands. They knew how to improvise solutions with limited resources. The Depression had taught them how to make do with what they had. The squadron had been attached to multiple divisions throughout the Normandy campaign. They operated as a 5th Corps asset, moving between units as needed. By early July, they had supported the 2nd, 4th, and 9th Infantry Divisions. They had fought through the bocage from Omaha Beach inland. They had lost men and vehicles. They had seen firsthand what the hedgerows did to American armor and infantry. The problem was not that American tankers did not know what to do. They knew. Every briefing emphasized proper crossing techniques. Every training session drilled coordination with engineers. The doctrine was clear. The problem was that combat in the bocage did not follow doctrine. Every field was different. Every hedgerow was different. The Germans adapted faster than American doctrine could change. Curtis Culin had been in France for 5 weeks. He was 29 years old, a Depression-era kid from New Jersey who had joined the National Guard before the war. He had worked on cars and trucks since he was 16. He knew how machines worked. He knew how to improvise solutions with limited resources. His squadron had men with similar backgrounds, factory workers, machinists, welders. Together, they started developing ideas. The concept that emerged was simple. Instead of climbing over hedgerows, tanks could cut through them at ground level. The tank needed something to concentrate force at the base of the hedgerow. Steel prongs or teeth that would bite into the earthen berm. The tank's weight would drive the prongs through. The vegetation on top would collapse. The hedgerow would split apart. The raw material was everywhere. The beaches were still covered with German obstacles, Czech hedgehogs, steel beam barriers designed to rip the bottoms out of landing craft. Each hedgehog was 3 steel I-beams welded together in an X shape. The beams were high-grade steel, approximately 5 feet long, already cut and angled. There were thousands of them scattered across the invasion beaches. Culin went to the beach the next morning. He found a salvage pile near Vierville-sur-Mer. Czech hedgehogs stacked 20 feet high. He selected one that was intact, had the beams cut it apart with a borrowed cutting torch, and loaded 4 I-beam sections onto a truck. Total time, 45 minutes. Nobody questioned what he was doing. Salvage operations were happening constantly. He brought the beams back to the maintenance area and spent the rest of the day measuring and planning. Each beam needed to be approximately 4 feet long to provide enough penetration depth. The ends needed to be cut at an angle and sharpened to concentrate force. The prongs needed to be spaced wide enough to divide the hedgerow's mass, but close enough to prevent the tank from bellying up between them. The welding work started after midnight on July 9th. The maintenance area was quiet. Most of the unit was asleep. The only sounds were generators running and the occasional rumble of artillery in the distance. Culin worked alone under a tarpaulin to hide the light from his welding torch. He positioned the first beam against the Sherman's front hull, low, angled slightly downward. The beam had to be welded directly to the transmission housing for maximum strength. He tacked it in place, checked the angle, then laid a full weld bead. The steel was thick. The weld had to be solid. He worked slowly, making sure every joint was complete. His hands were steady despite having worked a full maintenance shift earlier that day. The second beam went on the opposite side. Symmetry was critical. If the prongs were uneven, the tank would pull to one side during a hedgerow breach. He measured twice, welded once. The third and fourth beams went in the center, spaced 18 inches apart. By 0300 hours, all 4 prongs were welded in place. The modification added approximately 300 pounds to the front of the tank. The steel prongs stuck out 42 inches from the hull, angled downward at 20 degrees. Culin stepped back and looked at his work. The Sherman looked strange, aggressive. The 4 steel prongs gave it the appearance of some kind of mechanical beast. The other tankers would probably laugh when they saw it. The officers would definitely have questions. But if it worked, if it let the Sherman cut through hedgerows without exposing the belly armor, then regulations could wait. He cleaned up the work area, hid the welding equipment, and walked back to his tent at 0400. He did not sleep. He lay on his bunk watching the canvas ceiling and thinking about what would happen if the modification failed. If the welds broke during impact, if the prongs bent, if the tank flipped over, if soldiers died because of something he built without authorization. But if he did nothing, soldiers would definitely die. That was not a possibility, that was a certainty. The hedgerows were killing Americans every single day. At 0630, Culin walked to the motor pool and found Captain James Depew, one of the squadron officers. He told Depew about the modification, showed him the welded prongs, explained the concept. Depew listened without interrupting. When Culin finished, Depew said they needed to test it before anyone from battalions saw it. If it worked, they could show senior command. If it failed, they would remove the prongs and reconsider the approach. They drove the modified Sherman to an abandoned field behind the American lines at 0900. There was a hedgerow there, typical Norman construction, approximately 4 feet of earthen berm, topped with 10 feet of dense brush and small trees. No Germans, no observers. Just Culin, Depew, and the tank crew. Culin climbed into the driver's position. Depew stood outside to observe. Culin started the engine, engaged the transmission, and drove toward the hedgerow at 10 miles per hour. The steel prongs hit the base of the hedgerow. There was a tremendous impact. The tank shuddered. For a moment, Culin thought the welds had failed, but the Sherman kept moving forward. The prongs bit into the packed earth. The tank's 30 tons of weight drove them deeper. The hedgerow split apart. Dirt exploded outward. Vegetation collapsed across the tank's hull. The Sherman burst through to the other side in 4 seconds. All 4 tracks stayed level. The belly armor never exposed. The main gun stayed on target. Depew was calling out observations. Culin could barely hear him over the engine noise. He reversed back through the gap, shut down the engine, and climbed out. Depew was examining the breach. The hedgerow had a ragged hole torn through it at ground level, approximately 8 feet wide. Clean breach, no explosives, no exposed belly, no vulnerable moment. Depew said they needed to show this to senior officers who could authorize wider adoption. What neither Culin nor his fellow squadron members realized was that word was already spreading. Other tank crews had watched tests of modified Shermans cutting through hedgerows. They saw tanks breaching at ground level without exposing belly armor. They saw a solution to the problem that had been killing them for 6 weeks. Tankers from other units started asking about the modifications. Some battalion commanders refused. The modifications were unauthorized. They violated Army regulations regarding vehicle alterations. Installing them could void warranties and create liability issues. Other commanders looked at their casualty reports and decided regulations could wait. Mechanics from other units learned the technique. They found Czech hedgehogs on the beaches, cut the I-beams to 4-foot lengths, sharpened the ends at angles, positioned them on front hulls low enough to strike hedgerow bases, spaced them to divide mass evenly, welded them solid with full penetration welds. The modifications spread through informal networks. A tank commander would see a modified Sherman and ask where it got the attachment. The crew would point to their motor pool. The tank commander would talk to his mechanics. The mechanics would find someone who knew the technique. By mid-July, mechanics in multiple battalions were installing hedgerow cutters. By July 13th, Culin had modified 9 tanks. Word spread through the division faster than anyone expected. Tank commanders who had lost crews in the hedgerows heard about the modifications from mechanics in the motor pool. Platoon leaders who watched their Shermans burn after exposing belly armor started asking questions. Where could they get the steel prongs? Who knew how to install them? How long did it take? Some battalion commanders refused outright. The modifications were unauthorized. They violated Army regulations regarding vehicle alterations. They had not been tested by ordnance. They had not been approved by Tank Destroyer Command. Installing them could void the Sherman's warranty, create liability issues, and result in disciplinary action if something went wrong. Other commanders looked at their casualty reports and decided regulations could wait. They had lost 30% of their armor strength in 3 weeks. Crews were refusing to cross hedgerows without engineer support. Engineer casualties were approaching 50% because German artillery targeted every demolition team. Something had to change. Culin showed mechanics from other units how to do the work. He walked them through the entire process. Find salvaged Czech hedgehogs on the beaches. Cut the I-beams to approximately 4 feet length. Sharpen the ends at a 30-degree angle. Position them on the front hull low enough to strike the hedgerow base. Space them to divide the mass evenly. Weld them solid, not just tack welds, full penetration welds that would hold under impact. Test the welds before declaring the job complete. The mechanics learned quickly. Most were experienced welders who had worked in factories or repair shops before the war. They understood structural loads and stress points. They knew how to make field repairs that would hold under combat conditions. Within 2 days, mechanics in 3 different battalions were installing hedgerow cutters on their unit's tanks. The modifications spread crew to crew and unit to unit through informal networks. A tank commander would see a modified Sherman cut through a hedgerow and ask where it got the attachment. The crew would point to their unit's motor pool. The tank commander would talk to his mechanics. The mechanics would talk to Culin or one of the other soldiers who had learned the technique. By mid-July, the knowledge was spreading faster than official communications could track. No official documentation existed. No engineering drawings, no approved specifications, no installation procedures. Just soldiers teaching other soldiers how to weld German scrap metal to American tanks because it worked, and the official solutions were getting people killed. Some mechanics made subtle variations, 5 prongs instead of 4, different angles, longer or shorter lengths. Each crew tested their own modifications and adjusted based on results. On July 14th, word reached division headquarters. An inspection officer noticed several tanks in the 2nd Armored Division had unauthorized modifications on their front hulls. He reported it up the chain. Instead of ordering the modifications removed, Division Commander Major General Edward Brooks requested a demonstration. General Omar Bradley was visiting 2nd Armored Division that day as part of pre-mission planning for Operation Cobra, the planned breakout offensive scheduled for late July. Brooks asked Bradley if he had time to see something interesting. Bradley agreed. They drove to a training area near Colombieres, where Culin's Sherman was waiting. Bradley arrived at 0730 hours. He saw the modified tank with its 4 steel prongs and asked what he was looking at. Culin explained the modification. Bradley listened and then asked for a demonstration. Culin climbed into the driver's seat. His crew mounted up. The tank backed away from a hedgerow approximately 50 yards. Bradley stood with Brooks and several staff officers. Culin engaged the transmission and accelerated toward the hedgerow. The Sherman reached 10 miles per hour. The steel prongs hit the earthen berm. The hedgerow exploded. Dirt and vegetation erupted outward. The tank burst through under a canopy of falling debris. 4 seconds. Clean breach. The Sherman emerged on the other side with all systems operational. Bradley stood there for a moment, not saying anything. Then he walked to the gap and looked at the torn hedgerow. The breach was approximately 8 feet wide. Ragged edges, base torn out at ground level. He asked Culin how long it took to install the modification. Culin said approximately 6 hours per tank if the welder knew what they were doing. Bradley asked if the materials were available. Culin said the beaches were covered with German obstacles, enough steel to modify hundreds of tanks. Bradley turned to his staff and said to get every ordnance unit in 1st Army working on this immediately. He wanted as many tanks as possible modified before Operation Cobra. The attack was scheduled for July 25th. That gave them 11 days. Bradley ordered Lieutenant Colonel John Medeiros from Ordnance to coordinate production. Medeiros was told to use every welder, every maintenance unit, every salvage team available. 3 out of every 5 tanks in 1st Army needed these modifications before the offensive started. Culin stood there watching generals and colonels discuss his unauthorized modification like it was official policy. Nobody mentioned court-martial. Nobody talked about regulations. They were talking about production schedules and welding crew assignments. For his work, Culin was recommended for the Legion of Merit. 3 other men from the 102nd Cavalry also received the Legion of Merit for their roles in developing and manufacturing the hedgerow cutter. Major Arthur Person and Captain James Depew, the squadron's senior officers who supported the unauthorized project. Captain Stephen Litton, who helped refine the design. Culin was the sergeant who built the prototype, but the final device was a collaborative effort. The official recognition understated the grassroots nature of the invention. Bronze stars went to the tank drivers who tested the early prototypes under fire. Technical Sergeant Harmon McNorton, Private John Huey. Bronze stars also went to the welders who manufactured hundreds of devices in field workshops. Technical Sergeant Wesley Hewitt, Technical Sergeant John Jessen, Technical Sergeant Ernest Hardcastle. These were the men who turned one experimental attachment into an Army-wide modification in less than 2 weeks. Over the next 11 days, American ordnance units worked around the clock manufacturing hedgerow cutting devices. Bradley had ordered Lieutenant Colonel John Medeiros from Ordnance to coordinate production. Medeiros established manufacturing priorities immediately. Every ordnance unit in 1st Army was assigned quotas. Welding crews worked in shifts. Salvage teams stripped Czech hedgehogs from the beaches faster than they had been removing them. The devices were called Rhino attachments. Some called them Culin cutters. Each device was slightly different because they were handmade in field workshops, but the basic design remained consistent. 4 steel prongs welded to the front hull, cut from German beach obstacles, angled downward 20 to 30 degrees, strong enough to split a hedgerow, spaced to divide the mass evenly. The work required skilled welders. These were not simple tack welds. The prongs had to withstand tremendous impact forces. Full penetration welds were essential. The steel had to be fused to the hull structure so it would not tear away on first contact. The men who did this work were experienced craftsmen. Technical Sergeant Wesley Hewitt had been a welder in civilian life. Technical Sergeant John Jessen had worked in a shipyard. Technical Sergeant Ernest Hardcastle had maintained industrial equipment. These were the men who turned one experimental prototype into hundreds of combat-ready modifications. The tank drivers who tested the first devices also received recognition. Technical Sergeant Harmon McNorton drove one of the first modified Shermans through a hedgerow under fire. Private John Huey tested another early model during combat operations near St. Lo. Both men received Bronze Stars for their role in proving the concept worked under actual combat conditions. By July 24th, approximately 500 tanks in 1st Army had been modified. Shermans, Stuarts, even some M-10 tank destroyers. The modifications covered approximately 60% of the armor going into Operation Cobra. Some units had modified nearly all their tanks. Other units had only a handful, but the capability was spreading faster than official channels could have approved it. Then the Germans noticed something had changed. German infantry first reported unusual American tank activity in late July. Forward observers noted that American tanks in some sectors were no longer always climbing over hedgerows. In certain engagements, tanks were cutting through at ground level. The reports were filed, but initially received limited attention. American tactics changed frequently as units learned and adapted. By late July, patterns emerged. German anti-tank crews reported that tactics which had worked reliably were failing more often. They would position guns to cover hedgerow crossing points, where American tanks typically exposed their belly armor during climbs. But increasing numbers of American tanks were breaching at ground level with frontal armor protected. Guns positioned for high-angle belly shots found themselves engaging frontal armor instead. Similar reports came from German positions across the front. American tanks were breaching hedgerows in seconds without exposing vulnerable points in ways that had not been common earlier in the campaign. Tactics that had worked for 6 weeks were succeeding less consistently. German anti-tank crews were losing their predictable advantage. Senior German officers tried to understand what had changed. They examined wrecked American tanks looking for modifications. What they found were crude steel prongs welded to the front hulls. The purpose was not immediately obvious. The steel looked like salvaged beach obstacles. Some officers thought it was improvised armor. Others thought it was designed to trigger mines before the tank's main hull reached them. Few understood it was specifically designed to exploit the hedgerow's construction. By late July, German defensive plans started adjusting. Anti-tank guns that had been positioned to fire at hedgerow crossing points were being moved. Units that had relied on the bocage to channel American tanks into kill zones were being repositioned. The hedgerows were no longer reliable obstacles. The psychological impact on German defenders was significant. For 6 weeks, the bocage had been their greatest asset. Every hedgerow was a defensive position. Every field was a strong point. The terrain did most of the work of stopping American armor. German infantry could fight from prepared positions and let the hedgerows do the killing. That advantage was gone. American tanks were cutting through hedgerows faster than German infantry could reposition. Defensive plans that depended on controlling specific gaps were useless when the Americans could make their own gaps anywhere they wanted. Units that tried to use old tactics found themselves being outflanked by Shermans that appeared from unexpected directions. Some German commanders tried to adapt by thickening their hedgerow defenses, additional obstacles, more mines, deeper fighting positions. But obstacles that stopped a climbing tank did not stop a tank cutting through at ground level. The modifications did not care about additional barriers. They cut through everything. Operation Cobra launched on July 25, 1944. The offensive began with a massive aerial bombardment. Over 1,500 heavy bombers and 350 medium bombers dropped more than 4,000 tons of bombs on German positions south of St. Lo. The bombardment was meant to shatter German defenses and open a corridor for American armor to exploit. The first day results were mixed. The bombing had been partially effective, but also caused significant American casualties from short drops. Ground forces advanced, but encountered stiff German resistance in many sectors. The hedgerows still channeled movement. German defensive positions still took advantage of every piece of terrain. But tanks equipped with hedgerow cutters made a difference. They could breach at unexpected points. They could create their own gaps instead of using predictable crossing points. They could support infantry advances without waiting for engineers to blow paths through every hedgerow. The tactical flexibility was significant even if the devices did not revolutionize the battle overnight. First Army advanced 7 miles on the first day, 12 miles by the second day. German defensive lines that should have held for days were overrun in hours. By July 28th, American forces had achieved a breakthrough. German units were withdrawing. The bocage stalemate was over. By July 31st, the breakout was complete. American armor was in open country beyond the bocage. Third Army under General Patton passed through this gap and began its rapid advance across France. The hedgerows that had protected German defenders for 6 weeks were behind the advancing American forces. The hedgerow cutters played a supporting role in this success. Historians debate their tactical importance. Some argue they were psychologically significant, boosting morale and giving tankers confidence. Others argue the devices had limited practical effect, since armor primarily advanced on roads during the breakout rather than cross-country. The truth likely falls somewhere between. The modifications helped in specific tactical situations and contributed to overall combat effectiveness without being the single decisive factor. German commanders filed reports trying to explain how American forces had achieved such rapid breakthrough. Most cited overwhelming firepower and air superiority. Some mentioned new tank tactics. Few understood that the breakthrough started with scrap steel welded to tank hulls by soldiers who did not wait for permission. The modification was never officially credited to any engineering department or design bureau. After the war, American armor development reports mentioned hedgerow cutting attachments as field expedient modifications developed in theater. Curtis Culin's name appeared in some unit histories, but not in official Army documentation. Culin did not receive public recognition during the war. He was awarded the Legion of Merit in September 1944 for exceptional service. The citation mentioned his contribution to armored operations in Normandy, but did not specify the hedgerow cutter invention. 4 months after the demonstration for General Bradley, Culin was wounded by a German landmine in the Hürtgen forest. The explosion severed his left leg below the knee. He was evacuated to a field hospital, then to England, then back to the United States. His war was over. He spent 6 months recovering at an Army hospital in New Jersey, physical therapy, learning to walk with a prosthetic leg, adjusting to the reality that his tanker days were finished. He was discharged from the Army in March 1945 with a Purple Heart and a medical retirement. Culin married Bernice Enright in June 1945. They settled in New York City. He took a job as a salesman for Schenley Industries, a liquor distributor. The work was different from anything he had done before. No more tanks, no more maintenance, no more welding German scrap metal in the dark, just sales calls and client meetings and trying to build a normal life. He did not talk much about the war. When people asked, he would say he worked on tanks in Normandy, fixed engines, maintained equipment. That was all. He never mentioned the hedgerow cutters unless someone specifically asked. Even then, he kept it brief. It was just something that needed doing. He emphasized the collaborative work, the other men from the squadron who built and tested the devices. Veterans of the 102nd Cavalry kept in touch after the war. They formed an association, held reunions, maintained the history of their unit. The hedgerow cutter remained a source of pride. The squadron's official history documented how enlisted mechanics and officers worked together to develop a battlefield innovation that senior command quickly adopted. General Bradley mentioned the hedgerow cutter in his memoir A Soldier's Story, published in 1951. He described watching the demonstration and realizing that sergeants and mechanics had solved a problem that had stalled First Army for weeks. Bradley wrote that the device was so absurdly simple it had baffled an army for more than 5 weeks. He credited Curtis Culin by name, though he incorrectly listed him as Curtis G. Culin Jr. rather than the third. President Dwight Eisenhower mentioned Culin in one of his last speeches as president in January 1961. Speaking to the American Society of Mechanical Engineers, Eisenhower told the story of a sergeant who had an idea about putting knives on tanks to cut through hedgerows. Eisenhower said the idea went from captain to major to colonel until it reached General Bradley, and Bradley acted on it immediately. Eisenhower used the story to illustrate that innovation in wartime comes from soldiers in the field, not from headquarters. Eisenhower repeated the story in 1964 during a CBS interview with Walter Cronkite. The interview was filmed in Normandy on the 20th anniversary of D-Day. They stood near a hedgerow. Eisenhower described how the bocage had nearly stopped the American advance, and how one sergeant's improvised solution changed everything. He said the invention gave the Army back its mobility and made Operation Cobra possible. Curtis Culin never saw most of this recognition. He lived quietly in New York City working as a salesman. He and Bernice divorced in the early 1950s. He continued working for Schenley Industries. He walked with a prosthetic leg and rarely mentioned his military service. In 1963, Curtis Culin died of a heart attack in Greenwich Village. He was 48 years old. His obituary in the New York Times mentioned his service in World War II as a tank sergeant. It mentioned the Legion of Merit. It did not mention the hedgerow cutter. It did not mention that his modification helped break the stalemate in Normandy. It did not mention that he violated regulations to save lives. There is a memorial to Curtis Culin in his hometown of Cranford, New Jersey, a bronze plaque mounted on a boulder outside the municipal building on North Union Avenue. The plaque includes Eisenhower's quote about the sergeant who had an idea. A street in Cranford was also named Culin Drive in his honor. Residents walk past the memorial daily. Most do not know the full story. Most do not know that the modification was initially unauthorized. Most do not know about the other men from the 102nd Cavalry who contributed to the invention. In 1998, a military historian researching Operation Cobra found references to hedgerow cutting modifications in 2nd Armored Division maintenance logs and 102nd Cavalry Squadron records. The historian tracked down surviving members of Cullin's unit through veteran registries. Several remembered Culin. They remembered the modified tanks. They remembered the demonstration for General Bradley. They remembered that the modifications spread through multiple units in less than 2 weeks through informal soldier networks. The historian estimated that the hedgerow cutters contributed to reducing American tank casualties in the bocage, though precisely quantifying the impact remained difficult. The devices changed tactical options available to tank commanders. Instead of exposing belly armor during every hedgerow crossing, tanks could breach at ground level with frontal armor protected. Instead of waiting for engineers to blow gaps, armor could create breaches on demand. Instead of predictable crossing points that German gunners could cover, American forces could attack from varied directions. Post-war analysis by the United States Army Center of Military History examined the Normandy campaign in detail. The studies concluded that multiple factors contributed to the eventual breakout from the bocage. Overwhelming Allied air superiority, superior numbers of tanks and artillery, better logistics, improved combined arms coordination between infantry, armor, and engineers. The hedgerow cutters were one tactical innovation among many that collectively enabled Operation Cobra's success. Military historians continue to debate the hedgerow cutter's significance. Some emphasize its psychological importance. The modifications boosted morale among tankers who felt they finally had a tool to deal with the bocage. Knowing they could cut through hedgerows without exposing vulnerable bellies gave crews confidence to push forward more aggressively. Other historians emphasize tactical flexibility. Even if tanks often advanced on roads during the breakout rather than cross-country, the option to breach hedgerows at unexpected points forced German defenders to spread their limited anti-tank assets more thinly. German units could no longer concentrate defenses at a few predictable crossing points. Still, other analysts argue the devices had limited practical effect. Most armored advances during Operation Cobra followed roads and existing gaps rather than cutting through hedgerows systematically. The massive aerial bombardment and overwhelming force concentration mattered more than any single tactical modification. The hedgerow cutters helped at the margins, but did not fundamentally change the battle's outcome. The truth likely encompasses all these perspectives. The hedgerow cutters were neither the decisive war-winning innovation that some popular accounts suggest, nor were they militarily insignificant. They represented an important example of how frontline soldiers identify problems and develop practical solutions faster than official channels. They demonstrated that tactical innovation often emerges from the bottom up rather than top down. The story also illustrates organizational dynamics in military forces. The 102nd Cavalry developed the modification outside official channels because official channels moved too slowly. Ordnance was studying the hedgerow problem. Engineers were testing demolition techniques. But none of these official efforts produced a solution that spread widely enough, fast enough, to help the units fighting in early July. The soldiers built what they needed with materials at hand. General Bradley's decision to embrace and rapidly scale an unauthorized modification showed leadership flexibility. He could have ordered the devices removed for violating regulations. He could have insisted on formal testing and engineering approval. Instead, he recognized a practical solution and mobilized Army resources to manufacture hundreds of devices in less than 2 weeks. That kind of rapid decision-making, bypassing normal bureaucratic processes when circumstances demanded speed, contributed significantly to American success in Normandy. That is how innovation actually happens in war, not through official channels or engineering committees, but through mechanics and tankers working together to solve problems, through soldiers welding scrap metal to tanks because it worked, through crews testing modifications under fire, through junior officers and senior enlisted men willing to break regulations when lives were at stake. Curtis Culin received the most public recognition, but the hedgerow cutter was the work of many hands. The welders who built hundreds of devices in field workshops, the tank drivers who tested early prototypes, the officers who supported the unauthorized project, the mechanics who spread the technique across multiple units. All of them contributed to a battlefield innovation that changed the course of the Normandy campaign. Curtis Culin was not supposed to modify his tank. He was not authorized to weld German steel to Army equipment. He was not cleared to change his vehicle's performance characteristics. The regulations existed for good reasons. Unauthorized modifications could compromise safety. Untested changes could cause equipment failures. Field mechanics lacked the engineering expertise to evaluate structural loads and stress factors that professional designers considered. But Culin did it anyway because the official solutions were not working fast enough and soldiers were dying. That tension between following proper procedures and taking action to save lives defines many military innovations. Sometimes the rule book provides the answer. Sometimes survival requires writing a new page. The hedgerow cutter story became part of American military culture. Officers studying at command and staff colleges learn about it as an example of tactical innovation under pressure. The case study illustrates how frontline units adapt to unexpected battlefield conditions. It demonstrates the value of decentralized initiative and empowering junior leaders to solve problems. But the story also gets simplified in the retelling. Popular accounts often credit a single genius sergeant who saved the Normandy campaign. The reality was more complicated and more collaborative. Multiple units developed hedgerow breaching devices simultaneously. The 79th Infantry Division had cutters operational by early July. The 19th Corps tested prong devices. The 5th Corps units built their own versions. Culin's contribution was one among several, distinguished by the fact that senior commanders saw his demonstration and decided to scale it army-wide. The 4 men from the 102nd Cavalry who received Legion of Merit medals, Major Arthur Person, Captain James Depew, Captain Stephen Litton, and Sergeant Curtis Culin, represented a team effort. The welders who built hundreds of devices, Wesley Hewitt, John Jessen, Ernest Hardcastle, turned the concept into mass production. The tank drivers, Harmon McNorton and John Huey, proved it worked under fire. All of them contributed essential pieces. 50 years later, military analysts studying the Normandy campaign identified the hedgerow cutter as one of several key tactical innovations that enabled the Allied breakout. Not the breakthrough weapon that single-handedly won the battle. Not a minor footnote without significance. One important factor among many that collectively overcame the bocage stalemate. The Czech hedgehogs that provided raw material had been placed on Normandy beaches by Field Marshal Erwin Rommel's engineers. They were part of the Atlantic Wall defensive system, designed to destroy Allied landing craft. Thousands of them lined the invasion beaches, steel obstacles meant to stop the liberation of France. American mechanics turned those obstacles into weapons that helped break the German defense. They cut apart Rommel's beach defenses and welded the pieces onto tanks to penetrate his hedgerow defenses. The irony was lost on few observers. The Germans built elaborate obstacles to protect Fortress Europe. American sergeants recycled that German steel into tools that helped dismantle Fortress Europe. That kind of tactical and material improvisation characterized much of the American approach to World War II. The United States entered the war with less military experience than its adversaries. American forces had not fought a major war since 1918. Equipment and doctrine were often inadequate for actual combat conditions. But American units adapted quickly. Frontline soldiers identified problems. Mechanics and engineers devised solutions. Officers flexible enough to embrace unauthorized innovations gave their units tactical advantages. The hedgerow cutter represents a specific case of a broader pattern. American forces did not always have better equipment or tactics than their opponents, but they consistently showed ability to learn, adapt, and implement changes faster than enemy forces could counter them. That adaptability, more than any single weapon or tactic, contributed significantly to eventual Allied victory. In the town of Colombières, in Normandy, near where General Bradley watched the first demonstration in July 1944, there is a small museum dedicated to the liberation. The museum displays artifacts from the Normandy campaign, photographs of soldiers, equipment used in the fighting. Among the exhibits is a section of steel beam from a Czech hedgehog, the type of material American mechanics used to create hedgerow cutting modifications. The label identifies it as scrap from German beach obstacles, repurposed by American forces to solve the hedgerow problem. Tourists photograph it during summer visits. Most do not understand the full significance of what they are looking at. Most do not realize that pieces of steel like this, salvaged from invasion beaches and welded onto tanks by soldiers working through the night, changed tactical options during a critical phase of the Normandy campaign. The museum also displays photographs of modified Sherman tanks, the distinctive 4-prong attachments visible on their front hulls. The images show tanks pushing through hedgerows, dirt and vegetation exploding outward, the kind of breakthrough that had seemed impossible in early July. Veterans sometimes visit and point out details in the photographs, remembering specific battles, specific fields, specific moments, when those modifications made the difference between getting through a hedgerow or getting killed trying. The modification worked because Curtis Culin and his fellow mechanics understood that complex problems sometimes have simple solutions if you are willing to ignore the rules long enough to test an idea. The Army spent weeks trying to solve the hedgerow problem through official channels. Engineers tested explosives, ordnance evaluated bulldozer attachments, commanders revised tactical doctrine. None of it worked well enough. The solution came from soldiers who grabbed German scrap metal and started welding. If you found this story compelling, please take a moment to like this video. It helps us share more forgotten stories from the Second World War. Subscribe to stay connected with these untold histories. Each one matters. Each one deserves to be remembered. Leave a comment telling us where you're watching from. Our community spans from Texas to Tasmania, from veterans to history enthusiasts. You are part of something special here. Thank you for watching, and thank you for keeping these stories alive.